Hello everyone. So this is the third video of the series where I would be solving lead code problems for you. This is problem number 167 to sum. Input array is sorted and the difficulty level of this problem is medium. So let's start by understanding the problem first. Given a one indexed array of integers, numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where 1 is greater than equal to index 1 uh, and index 1 is greater than equal to index 2, and then again index 2 is greater than equal to numbers dot length. So the first paragraph says that we would be having a numbers array that would be indexed from 1 and not 0, and it would be sorted in a non-descending order, which means in an ascending order. We need to find two numbers that add up to a specific target number that would be given to us. Now the index of these two numbers would be between 1 and the total number of numbers in the numbers array, basically the length of the array. So what we have to return is, we need to return the indices of the two numbers index 1 and index 2 added by 1 as an integer array, index 1 comma index 2 inside an array of length 2. So what we have to return is, we have to return these two indexes, and these two indexes should be added by 1 as an integer array. So let's say if the indices that we founded are 0 and 2, it should be actually shared back as an array of 1 and 3. Okay, the tests are generated such that there is exactly one solution. You may not use the same element twice. So this line says that all the test questions or all the input values are generated in a way that there would be exactly one solution. There won't be more than one solution, and you may also not use the same element twice. So let's say the target is 4 and in our array there is 2, so we cannot say 2 at 0th position, so we cannot say 1 comma 1. We cannot use the same 2 two times. Okay, so your solution must use only constant extra space. Cool. Let's go through the constraint once. So the constraints are 2 is less than equal to numbers dot length, which is less than equal to 3 into 10 to the power 4. Okay, so this says that the length of the numbers array would be greater or equal to 2 or less than equal to 3 into 10 to the power 4. Next thing is, the numbers at I would be between minus 1000 and plus 1000, less than equal to or equal to greater than equal to plus minus 1000. Numbers is sorted in non-decreasing order, and target would again be less than equal to and greater than equal to plus minus 1000. The tests are generated in such a way that there is exactly one solution. Now let's go through the examples once. Now the input would be is numbers it is an array of 4 elements where we have 2, 7, 11 and 5, and the target number is 9. So we have to find the indices such that 2 elements add up to 9. So in our first case, 2 and 7, they add up to 9. The indexes are 0, 1, and since we had to add add 1 to it, it's a 1 indexed array. So 0 plus 1 would be 1 and 0 plus 1 would be 2. So our resultant output array is 1, 2. Similarly, if we look at the second example, we have the numbers as 2, 3 and 4 and the target number is 6. Here our answer is 0. At 0th element we have 2 and at the second element we have 4. 2 plus 4 is 6. So 0 plus 1 would be 1 and 2 plus 1 would be 3 and our output array is 1, 3. Similarly, we'll go forward and the next example would be solved. So let's see how I have attempted to solve this. Here from the function we would be getting the numbers array and we would be getting the target. Now to store the length of this numbers array, I have declared a variable, a let variable. This would be storing the numbers dot length. Here I have used two pointers method. I would be starting from 0, the 0th element of the numbers, and I have taken the second pointer at the last element of the numbers, so it is numbers num length minus 1. Now what I have done is I have taken a while loop where this loop will run until our starting point is less than the end point. Okay, so while we are inside this loop, we are adding the two numbers that are at the start position at the end position. So let's go by the first example. We are first taking 2 and then we are taking 15, we are adding it and the result is 17. Now we are checking if sum is equal to target. In our first case, 17 is not equal to the target, which is 9. So we won't go inside the first if loop. Then we'll check if sum is greater than the target. So sum, which is 17, is actually greater than the target, which is 9. So we'll go inside this loop and we'll change our end pointer to point to the element 11. Okay, so now our pointer is at 11 and we'll check again if our start point is less than end point or not. So start was at 0 and the end point is now at 2. So yes, it is less than 0. Again we'll come and we'll calculate the sum. So numbers at start is 2 and numbers at end is 11. 2 plus 11 is 13. Okay, so here let's write it as 13. Now again we'll check if sum is equal to target, which is not. So 13 is not equal to 9. So we won't go inside this loop. Then we'll check if sum is greater than target, which is true. 13 is greater than target. So again we'll reduce the from the end. We'll reduce the pointer from the end. Now our pointer is at 1 and at the element at position 1 the element is 7. So we'll again loop. We'll check if start point is less than end point. which is true. 0 is less than 1. We'll again change the sum. 7 plus 2 is now 9. Our first condition is met if sum is equal to target. So 9 is equal to 9. So we'll go inside this loop, and what we will do is we'll return an array where the start point is increased by 1 and the end point is also increased by 1 to fulfill the condition, to fulfill this condition here. So this is how we will get the result. Now those who are wondering why are we increasing the pointer or decreasing the end pointer, what is the condition, why we have this if else condition here. So what we are doing is we have taken two pointers, one at the start and one at the end. Whenever we find and we inside our while loop we are adding the elements at these two pointers. Whenever we find that the sum of these two elements, the start and the end pointer, is greater than our target pointer, we are decreasing the end pointer, because if we'll increase the start pointer, the sum would still be greater than the target and it will never serve our purpose. But if we'll decrease the end pointer, and this means that the target, the sum of the next two pointers would be less than the target pointer, or would be much closer to the target pointer. So this is the reason why we are decreasing the end pointer. Similarly, if the sum is less than the target pointer, what we'll do is we'll increase the start pointer so that we move close to the target pointer. This approach is a really nice approach. The time complexity of this approach is actually O to the power n, which is actually good. So this it's actually good for the solution like this. So yep, that is how we'll solve this. Thank you.